Hello everyone. This video is on the Knewton Alta assignment for section 2.2, part 1, called Solve Equations with the Division and Multiplication Properties of Equality. Alright, so in this video, I'm going to be taking you through a preview version of this particular assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But all the objectives are the same, the structure is the same, so I'm hoping that watching me do these examples here help you in some way when you're working on the assignment on your own. Alright, so here's the assignment page. You should have the title of the assignment, the mastery bar telling you how far along you've gotten. You can see all the objectives for the assignment. It looks like there are 3 objectives for this assignment. And then under the current objective, there is a question related to that objective. And at the bottom of every question, you should be seeing a feedback button, where if you see any issues with a problem, you can send feedback to Knewton. You will not have this instructor cheat button. This is for instructors only. But you will have a more instruction button, which can be very useful. If you're ever struggling with a topic or a question, click on more instruction. You'll be taken to a page with some further reading or videos or both on that objective, and then you'll be given questions related to that instruction, and doing those questions correctly can progress you through the assignment. And you can work through the entire assignment in the more instruction area if you wish. Just keep on hitting more instruction. Nothing wrong with that. Okay. So this first objective I'm looking at is solve an equation using the division and multiplication properties of equality. Now, I did in section 2.1 part 2, the video for that assignment, I did bring up the multiplication and division properties of equality, and I'll go over them again here, of course. So let's do that. Right, so I had these written out last video. Here they are, the multiplication slash division properties of equality. So what this states is that if you have an equation, if A equals B, let's say, and you have some number that's not 0, say C is not 0, then A times C will be equal to B times C. Basically, if you multiply the left side by C, you must also multiply the right side by C. Now, here C could be 0. You'd get a true statement, 0 equals 0, but that's uninteresting. We do not want to multiply both sides of an equation by 0, because that'll just make everything disappear. 0 equals 0 is true, but it eliminates any information we wanted to find. So that's why I'm having C not be 0 there. Also, A divided by C would be equal to B divided by C, right? Dividing both sides by C. And again, you want C to not be 0, because dividing by 0 is undefined, right? That's not good. You can't divide by 0. And again, just like for the addition and subtraction, these properties are basically telling you if you have an equation and you do something to one side, you should be doing the same thing to the other side to keep the equality true. Alright. So now the equation we're given in this first problem is this. Solve this equation. N divided by -4 equals -34. and I want to solve for n. I want to get n alone. N equals, some number that when I replace n with that number, it would make this a true statement. Well, right now I have n divided by -4. To undo division, you perform multiplication. So if I wanted to get rid of that -4, I would multiply by -4 times -4. And I would do the same exact thing on the other side, right? This multiplication property of equality. So the other side is -34, and I'm going to multiply by -4. All right, so over here, -4 in the numerator, -4 in the denominator, those cancel. I'm left with just one n by itself, n equals. And then hopefully you remember your multiplication properties, right? Negative times a negative is a positive number. And 34 times 4, 4 times 30 is 120, plus, and then 4 times 4 is 16, 120 plus 16 is 136. And there you go. And please check your solutions as well before you submit them, right? Because you don't want to get things incorrect in the Knewton Alta assignments, right? If you get things wrong, it'll just make you have to do more problems to complete the objectives. So check, plug this back in. 136 divided by -4 is indeed -34. So this works out. This makes that a true statement. And that's what I'll enter back in the assignment. It already has the n equals, so I'm just putting the number, right? The solution, 136. Great. And after every problem, it'll tell you if you're right or wrong, and then give you, now sometimes when you're wrong, it'll give you another chance to get it right before moving on. So hopefully you get it right on the second shot. But if you get it wrong after the second shot, then it'll just tell you right or wrong, and then you'll see an answer explanation. Please read through the answer explanations. That way you can figure out why something was right or why something was wrong, and hopefully you can learn from your mistakes for future questions. Okay, next. Pardon me. Alright, so it looks like we're still in the same objective. You see we've made some progress there now, about a quarter of the way done. And it's a very similar looking question. So I'm going to do the same thing. We have n divided by -20 equals -7. So again, you take the left side, n divided by -20. The right side is this -7. If I want to get n alone, it's being divided by -20. To undo that, to get rid of that -20, I need to multiply by -20, right? And I'm doing that on both sides. So on the left side, the -20s divide out to be 1, they cancel. And I've got n by itself equals, and then -7 times -20 will be positive 140. And there's your solution to that equation. And again, please check it, plug it back in, make sure the original statement is true when n is 140, and it should be. So n equals 140. Great. All right. Now we've switched objectives. Solve an equation that requires simplification using the division and multiplication properties of equality. Alright, so I'm going to go over this example here in two different ways, and you decide which one you like better. Alright, they both give me the same result, but you decide which one you like better. This is how to deal with equations that have fractions. Alright, so I'll write this equation out. Alright, so we're given s, that's 1s, right, if you think about it, right, 1 times s. plus, and then a quarter, 1/4 times s equals, and then on the other side we have -6 minus 3/2. Alright. Now on the left side, now you can keep the fractions. Alright, so this is method 1. The first method is keep the fractions the way they are, and then we combine stuff. Right now, when you combine like terms over here, right, both these terms have s in it. So we're going to have so much s. You add the numerical coefficients, right? So we need to know what, and I'm going to do this off to the side, we need to know what 1 plus 1/4 is. Well, remember, to add you need the same denominator, and 1 is just like 1 over 1. I would have to multiply that by 4 over 4, right? So 4, that's 4/4. 4/4 is 1 plus 1/4, and 4/4 plus 1/4 is 5/4. So when I combine 1s with 1/4 s, that's 5/4 times s, 5/4 s. And then over here, again, adding and subtracting, you need a common denominator. -6 is the same as -12 divided by 2, right? -12/2. To get a common denominator with this minus 3/2. Alright, so -12 minus 3, it's -15 in the numerator, and then halves, right? Remember that when the denominator is the same, and you're adding and subtracting, that's what the denominator will be in the sum or the difference. So we have now 5/4 s equals -15/2. And now you can divide by 5/4, but you might remember this from an earlier lesson or an earlier point in your mathematical career. Remember division? Division is just multiplication by the reciprocal. So instead of dividing by 5/4, I'm going to multiply, and I only do this really with fractions, but instead of dividing both sides by 5/4 to get s ln, I'm going to multiply by the reciprocal of 5/4, which would be 4/5, times 4/5, and do the same thing over here, times 4/5. Now when you multiply fractions, the denominators don't need to be the same. When you multiply fractions, you multiply the numerators, multiply the denominators, and then simplify. Or you can simplify first and then multiply. But here the 4's would cancel, 5's would cancel. This is 20 over 20, which is 1. 1s. Any number multiplied by its reciprocal will be 1. So now I have 1s on the left, s is alone. And then over here, this would be, -15 times 4 is -60. Divided by 2 times 5 is 10, and then this is, -6. They have a common factor of 10. Or you could have done this, 5 goes into 15 3 times, that'd be -3, and then 2 goes into 4 twice, so it would be -3 times 2, which is -6. Right? Either way you do it, you end up with s equals -6. Okay, so that's one way to do that. You can leave the fractions as fractions and work with the equation as usual, combine like terms, and then once you have a number times s, you divide by that number or multiply by the reciprocal of that number. Right? Remember, again, division is multiplication by the reciprocal, and get the variable alone equals some number. And then of course check your solution afterwards. Now the alternate method, we can say or, we could do it this way. And we had s plus 1/4 s on the left side, all that, equals, and then, the entire right side was -6 minus 3/2. You can multiply both sides if you have fractions. Multiply both sides by the least common multiple of the denominators, or what's called the least common denominator. The denominators here are 4 and 2. The least common multiple of 4 and 2 is 4. Right? 4 is a multiple of 4, obviously. 4 is also a multiple of 2. So I can multiply both sides, every single term, by 4. All right, times 4, times 4. And that's the LCD. That's the least common denominator that I'm multiplying by, LCD. Now each side has multiple terms, so I need to distribute the 4. Same thing over here. There are 2 terms in that sum or difference, so I need to distribute the 4. Now 4 times s is 4s, plus the whole reason we multiply by 4 is to get rid of the denominators. 4 times 1/4, the 4's would cancel and I'd be left with 1s. See how the denominators are gone. That would be 4/4 or 1s. Then on the other side, negative 6 times 4 is negative 24. And then negative 3/2 times 4 would be negative 12/2 or negative 6, right, when you simplify. And now you see no more fractions, no more denominators. Multiplying both sides by the least common denominator or some common multiple of the denominators will do this. We'll get rid of the fractions. It'll get rid of the denominators. And now we can easily do this. 4s plus s is 5s. Negative 24 minus 6 is negative 30. And then I divide both sides by 5 to get s alone, right? Because right now it's s times 5. I undo that by dividing by 5. Or you can multiply by 1/5. All right, dividing by 5 is the same as multiplying by 1/5, but whatever. And on the left side you have s, and on the right side negative 30 divided by positive 5 is negative 6, and I get the exact same number I got earlier. And that should be a solution, right? I found the same thing in 2 different ways. It should work. Now you can plug it back into the original equation and see that it works, but it should. Right? But yeah, so this method here I find more people enjoy. Yeah, you look at all the denominators throughout the equation and multiply both sides by the least common denominator, least common multiple of the denominators. And that will lead you to an equation that has no more fractions. And then you can solve that after that. So if I ever see an equation with fractions again after this, that's what I'm going to be doing, because I find it simpler for people to gather as the grasp is multiplying both sides by the LCD. So s equals negative 6. Yeah. Wonderful. Yeah, see, they did it here the first way that I showed you, where you just keep the fractions and do all that. But there's that alternate method as well, multiply both sides by the LCD. Alright, so now we're jumping to the other objective, the third objective that we haven't seen yet. Solving an equation involving fractions or decimals using the division and multiplication properties. Alright, so this one has fractions again. And we're asked to enter our solution as enter a fraction or a whole number, depending on what the solution is. Alright, now this one, again, you can do this in a couple ways, depending on what you find more comfortable. So it's 7/20 times n equals 8/5. And you can just get the n alone right now. To get n by itself, it's being multiplied by 7/20. So I would then divide by 7/20. But I don't like dividing by fractions. So remember what I said earlier, right? Dividing is the same as multiplying by the reciprocal. Dividing by 7/20 is the same as multiplying by 27ths, right? The reciprocal, just flip the fraction. And if I'm doing that on the left, I'm also doing that on the right. Now the 20s here cancel, the 7s cancel, right? They're common factors in the numerator. So that leaves me with n on the left. Over here, you got 5 and 20. 20 divided by 5 is 4. 5 goes into 5 once. 5 goes into 24 times. And those look like the only common factors in the numerator and denominator. And then we multiply. 8 times 4 is 32 in the numerator. 1 now times 7 is 7 in the denominator. And that's as simple as that fraction gets. And there's your solution. N equals 32/7. Now again, you could have also done it the other way with that least common denominator. I had 7/20 times n equals 8/5. Right, the least common denominator, the LCD, would be 20. Right? 5 and 20 are the denominators here. 20 is the smallest common multiple of 5 and 20. So I'll start off with that. I'll multiply both sides by 20. And here the 20s cancel. You're left with 7 times n. And here 5 goes into 24 times. You're left with 8 times 4, 32. And then you would divide by 7. Then divide by 7 to get n alone. And you get the same exact solution, right? N equals 32/7. It's the same exact thing I got earlier. Now multiplying by 20 and then dividing by 7 is exactly the same as multiplying by 27ths. So these were really the same method, just kind of broken up into pieces. So the final solution here, n equals 32 divided by 7, 32/7. Great. All right. Next question, now we're involving decimals. Now, I'm going to recommend highly getting rid of the decimals. All right, you don't have to. You really don't have to. But either writing the decimals as fractions or just multiplying by some power of 10 to get rid of the decimals. So let me show you. All right, so here, I'll write this equation out. We got negative 0.3 times n equals negative 0.033. If you were to think, again, I'm going to say, multiply both sides by some power of 10 to get rid of the decimals. I'll say get rid of the decimals with multiplication. Now here's how we do this. This one I'd have to multiply by 10, and this one I'd have to multiply by 1,000 to get rid of the decimal, and that's the bigger one. So I need to multiply both sides by 1,000 here. Just take the biggest number that would get rid of all the decimals and multiply by that. Right? So we have to multiply both sides by 1,000. Now if I do this, remember multiplying by 1,000 moves the decimal place to the right 3 places. So this would be negative 300n. Right, if I move that over 1, 2, 3, it'd have 2 zeros, negative 300n. And then here it'd just be negative 33. Right, if you move the decimal place to the right 3 places. So get rid of the decimals with multiplication, again, by a power of 10. 10, 100, 1,000, 10,000, 100,000, a million, whatever. Right. And now we have a simple one. Right? Just divide both sides now by negative 300, and that'll get rid of the 300s here, and then you'll have n alone. So n equals negative 30, well, it's going to be positive because it's a negative divided by negative 33 divided by 300, which if you take out, divide out the common factor of 3, this is 3 times 11, this is 3 times 100, so you have 11 hundredths. Now I'm guessing they're going to want you to enter the answer as a decimal. 11 hundredths is 0.11, right? That's 11 hundredths. Or remember, dividing by 100 moves dividing by a power of 10 moves your decimal point to the left so many places. Dividing by 100 moves it left twice, so that'd be 0.11. And there's your solution. All right. Positive 1100ths. But yeah, multiply both sides by some power of 10, 10, 100, 1,000, whatever, to get rid of the decimals and solve. Now, I'm pretty sure it'll take the fraction too. I'm going to check that. 11 over 100. That I mean, it is the solution, so it should take it. Yeah. So as long as your fraction or decimal, as long as your fraction's simplified though, right? 11 and 100 don't have a common factor, or you can write your final answer as a decimal, because I mean the original equation had decimals too. So either 11 hundredths or 0.11, same thing. Great. Alright, so here's another equation with a bunch of fractions. Alright, so like I said, I'm gonna do it that one way where we multiply both sides by some common multiple of the denominators, and I'd like the smallest one, right, the least common denominator. Alright, so the left side we have 7 halves times x plus 7 ninths times x equals negative 17 plus 25 sixths. Right, 25 over 6. Now the least common multiple of all the denominators, right, the least common denominator, the LCD, would be 18. Right, 2, 9, and 6. 18 is a multiple of all those, and it's the smallest one that would be the multiple of all those. So I'm going to take the entire left side and the entire right side and multiply them by 18. And since each side has multiple terms, this will involve distributing. Now, the whole reason we multiply by this is so the denominators go away. So in this first term here, 7 over 2, 2 goes into 18 9 times, and 9 times 7 is 63. So you have 63 times x. See, no more fractions. Plus, then the 7 ninths times 18. 9 goes into 18 2 times. You'd have 2 times 7. That's 14x. Alright, so see again, no more fractions. Then negative 17 times 18. 17, that'd be negative. Right? And then 17 times 18. 306. 170 plus 80 plus 56. 2 for 306. And then plus, and then again, the whole reason we're multiplying by the LCD is so the denominators will go away. Right? All these denominators should go into it evenly. 6 goes into 18 3 times, and then you'd have 3 times 25, or 75. And now I have an equation with no more fractions. It's a lot prettier. Right? Now if you combine the like terms on the left, 63x and 14x, that makes 77x. And then negative 306 plus 75, the negative number is bigger, so this will be negative. And the difference between 306 and 75 would be, let's see, 25, 225, 231. Right? Yeah, 231 and 75 make 306. So yeah, so this would be negative 231. And then divide both sides by 77 now to get the x alone. So x is equal to negative, right? You have a negative divided by a positive, so a negative number. Now 231 is 21 times 11. And 77 is 7 times 11, so I'm seeing the 11s cancel. And actually 21 divided by 7 is 3 as well, so this is negative 3. Alright, that simplifies to negative 3. And check it. go back to the original equation with all the fractions, plug in -3 for x, and see that you make the number on the left equal the number on the right when you simplify them. They should be, if I did everything correctly. So x equals -3. Wonderful. All right, and again, please read through the answer explanations. Alright, this one's pretty simple. I would just divide both sides by -18. So this is going to be a negative number. B equals negative. And now 32 divided by 18, that simplifies to 16/9, right? 32 is 2 times 16, 18 is 2 times 9. So we're asked to write it as a simple improper fraction, right? And 16/9 doesn't reduce any further, so that's it. B equals -16/9. Very simple one, that one. And again, they got the steps here. Alright, and once again, a very quick one. To get B alone here, I would just simply divide by -17. And you'd have B equals -21 divided by -17 would be positive 21/17. 21 and 17 don't have any common factors. So that's as simple as that fraction is going to get, and there's a solution. Great. Alright, so that objective's done where you're just doing a quick multiplication or a quick division. Alright, so now some more stuff with fractions and simplification. So here's another one that I'll write out. Alright, so on the left side, we have 9/8 times m minus 1/6 times m equals, and on the right side, -4 minus 11/3. Alright, so the LCD, the least common multiple of all these denominators, would be 24. Right, 24 is 8 times 3, 6 times 4, and 3 times 8. Right? And that would be the smallest multiple of all these numbers. So I'm going to take the entire left side, the entire right side, and multiply each term by 24. Right? I'll be distributing. And the whole point of this is to get rid of the fractions, right? Get rid of the denominators. So in this first term on the left, 8 goes into 24 3 times. You'd have 3 times 9, that's 27m. Alright, then we have minus, and then 6 goes into 24 4 times. 4 times 1 is 4. So you have 4m. Alright, and then on the other side, -4 times 24. It's 80 and 16. That's -96. Then minus, and 11/3 times 24. 3 goes into 24 8 times, and 8 times 11 is 88. And now I have an equation with no fractions, right, after multiplying through by the LCD. 27m minus 4m would be 23m. Then -96 minus 88 would be just more negative. Be 170, 184. 184. Yeah, 170 and 14. Yeah. And then we divide both sides by 23. Right? So m equals -184 divided by 23. And I'm pretty sure. No, that's 8. -8. 8 times 23 would be 160 plus 24. Should be 184. This is -8 when simplified. And there's your solution. M equals -8. And you can go ahead and check that back in the original equation, plug in -8 for m, and make sure you get a true statement. But I'll leave that to you. But you should get in the habit, though, of checking your solutions. Okay. And please read through the answer explanations. Alright, so I got one more of these. Now, this one's real nice. All the fractions that have actual denominators other than 1 have the same denominator. They're all 11. So this should be pretty quick. So we have 6 elevenths times n minus 3 elevenths times n equals -4 plus 23 elevenths. So the LCD here is clearly 11. So I'm taking both of these terms on the left and multiplying by 11. And both of these terms on the right times 11 as well. Right? Do whatever you do to the one side to do the other. So the 11's cancel at 6n minus, then the 11's cancel here. That'd be 3n. And then over here, -4 times 11 is -44. Plus, and then 23 elevenths times 11, the 11's would go away, you'd have 23. Right. 6n minus 3n is 3n. Then -44 plus 23 would be negative, and then the difference between 44 and 23 is 21. -21. Then dividing both sides by 3, n must be -7. Right, 3 times -7 is -21. Great. And again, if you want to check, please check the solution back in the original equation. Make sure it makes it a true statement. But if you're doing everything right, it should. So n equals -7. Great. All right, so that objective's done now. All right, then I got a couple more involving fractions and decimals. All right, this one's real simple. I would divide by 1/13. But dividing by 1/13 is just multiplying by 13. So I multiply this by 13, and when you multiply by 13, you just multiply the numerator by 13, the denominator by 1. 8 times 13 would be 80 plus 24, that's 104. No common factors in the numerator and denominator, so r would be -104 15ths. Alright, that one just a simple multiplication by 13 on both sides to get r alone. Cool. Alright, then one final one of these. Alright, again, no decimals here. So I'll write this one out. There's not just a single number I'm multiplying by. I mean, there is, but it's a fraction. Alright, so let's just do it here. There's space here. So that's 2/9 times r equals -6/13. And again, you can multiply both sides by the LCD if you want, but to get r alone takes just one step. You would divide by 2/9 or multiply by 9/2. Right, dividing is multiplying by the reciprocal, and I would do the same thing on the other side. So over here, the 9's are gone, the 2's are gone, right? And you have r equals, and then over here, you can multiply first, then simplify, or you can simplify first. 2 goes into 2 once, 2 goes into 6 3 times, right? 6/2 becomes 3/1. And then I don't see any other things with common factors in the numerator and denominator, so we have negative, 3 times 9 is 27 in the numerator, 13 times 1 is 13 in the denominator, and there's your solution. And don't forget to check it. But -27/13. -27/13. Great. Alright, and that should be it for this preview version of this assignment. As I said at the top of the video, please understand that the questions I saw here are not going to necessarily be the same questions you're going to see when you do the assignment yourself. But, all the objectives are the same, the structure is the same. So I'm hoping that watching me do these several examples here for each objective help you in some way when you work on the assignment on your own. And thank you very much for watching.